This is the ClickHouse ingestion mental model you have to take into account. We have seen this in other videos. Remember, you have parts, which are physical chunks created by inserts when you use the merge tree family. Then you have merges. These are background jobs that compact small parts into larger ones. And you have some kind of a budget because merges consume CPU, disk, memory, network bandwidth if you're using cloud storage. So you have to take that into account, okay? The model is simple. Whenever you insert some rows, it creates a number of parts depending on your partition key. There's this background process that compacts them in fewer parts. Okay, so remember, ClickHouse is designed for bulk inserts, not so much row by row streaming. And if you make parts faster than ClickHouse can merge them, what's gonna happen is you're gonna have a merge backlog, you're gonna have lag on your merge parts, and ultimately your queries are going to slow down because they need to read more parts that are not optimized. How many parts ClickHouse creates on each insert? Well, it depends on the number of rows you are inserting on each insert, the partitioning of your table. Remember that ClickHouse automatically creates one part for each partition. And then we haven't talked about materialized views, but materialized views are insert triggers, which means whenever you do an insert on a table, if there is downstream materialized views, it's gonna create parts for each materialized view, okay? And ingestion is not just about inserts. I mean, there is a fine balance between other things. Remember, we have merges, which have a kind of a budget because they use CPU, memory, disk, and network bandwidth. You have reads because they might be competing for resources. You have mutations, we already talked about them. Certain operations have to rewrite complete partitions. And of course, it depends on how you design your table. That's why it's important to understand how the engines work and how the partition key is important.